Hello everyone, my name is Devan Stoeling and today I will be showcasing one of my favorite experiments from doing organic chemistry at home, the Fundamentals of Chromatography. For this experiment, I was able to investigate and understand the common use of paper chromatography, where we will isolate food dyes to see the separation of mixtures and to monitor the progress of a certain reaction. This will allow me to identify what compounds are present in the given mixture. This will also help determine the purity of a substance and difference in polarity. There are four main techniques that are used for chromatography: paper chromatography, thin layer chromatography, gas chromatography, and liquid chromatography. So what is paper chromatography? Paper chromatography is an analytical technique used to separate colored chemicals and substances. It has become a standard practice in the chemistry world to help chemists separate complex mixtures such as amino acids, carbohydrates, steroids, and so much more. To begin with the experiment, a 0.10% NaCl solvent was made to be the mobile phase, and 2 grams of orange, grape, and strawberry Kool-Aid was mixed with 5 milliliters of pure water. Red number 40, yellow number 5, and blue number 1 dye colors were spotted on the chromatography strips, also known as the stationary phase, to observe the distant color band and the solvent front to calculate the RF values. They stayed in the test tube for about 15 minutes to allow the reaction to occur. Based on these results, red number 40 had the farthest travel distance than yellow number 5 and blue number 1. This shows that red number 40 is the most soluble, where yellow number 5 is the least soluble. These observations clarify that red number 40 is the most polar than blue number 1 and yellow number 5. The same procedure was repeated but with different colored compounds of Kool-Aid. You can see the mobile phase travel through the stationary phase, separating the compounds with it, also where different components of the compound stop absorbing. These results of the grape orange and strawberry flavor revealed that grape and orange separated into 2 different colored components, where strawberry Kool-Aid did not separate. This means that strawberry was the only pure compound which consisted of only red number 40 dye, whereas orange and grape consisted of 2 colored dyes, blue number 1 and red number 40 for grape, yellow number 5 and red number 40 for orange. We calculated the retention factor where the distance of the solute was divided by the distance of the solvent front to compare the distance of the bands. For example, strawberry Kool-Aid had a distant solvent front of 52 mm with a distant color band of 47 mm for red. The RF for red number 40 dye is 0.90. These results reveal that the strawberry Kool-Aid is the most soluble in the NaCl solvent because its value is closest to 1. In conclusion of this experiment, isolating dyes in homogeneous mixtures was successful by the technique of paper chromatography to identify the components, purity, solubility, and polarity of a specific mixture. Doing this experiment made me come to a realization that we deal with chromatography every day. For starters, creating vaccinations to determine antibodies to fight viruses and diseases such as Pfizer and Moderna for COVID-19. Forensic testing to analyze samples to identify a specific person, also beverage and food testing, and so much more. Despite being in a pandemic and not being able to experience this lab in an actual laboratory, chromatography at home was fun and informative. It truly opened my mind that as humans, we use and rely on chromatography every day, and we can continue using it for future research and resources.